Let's see the next interesting problem, maximum product subarray. Okay, this problem is basically like given an array of integer nums, find the subarray that has the largest product and return the product. Okay, let us take one example. Input nums is 2, 3, minus 2, 4. In this case, if you see the product of 2, 3 is the maximum. After that, everything, once you multiply with the minus number, everything will become negative. So it will go low. So maximum product is 6. In this case, minus 2 into 0. Actually, if you multiply with 0, this things will become 0 only. Correct? A continuation basically. Okay. So result cannot be 2 because minus 2 and minus 1 is not a subarray. And if you take individual numbers, minus 2 is less than 0 and minus 1 also less than 0. So this is the problem. We will take this problem and try to solve it. First, we'll see like how we can solve using the brute force as usual. After that, we'll try to optimize the same solution. Okay, let us take the input. Whatever the input we have given is 2, 3, and minus 2 and 4. So this is the input we have received, and we need to calculate the maximum product subarray, right? So first solution, as usual, we will go for brute force. Using brute force approach, basically we'll take two for loops, and it will be O of n square time complexity. Okay, O of n square. So what we will do now is we will try to solve this problem by going through this loop. So first we'll do what we will do is we'll take the maximum product, uh, maximum product we will take as the first element, whatever this one, that is 2 initially. Okay, and we'll iterate through the numbers from 0 to remaining numbers. So what we will do is we'll take the I value. Basically what we will do is I equal to 0 and j also start from 0. Okay, and j will continue from the remaining elements, and we'll see the maximum product what we will get. Okay, when we are actually starting from 0, we'll initialize the uh, current product also to 1 basically. Now we'll take the maximum product as well, and yeah, it will be initially with 1 we are with the first element I and j at the same position. So maximum product will be we already took 2, then that will be 2 only in this case, and current product also 1 into the number at the 0th position, that is 2. Okay, now j will increment the j and I remains same, j equal to 1, that means the j will be this position. Now we have 3. What we will do is we will try to multiply with current product, whatever product we we extracted till now, and the number, whatever number we have at position j, that is 2 into 3, 6, right? Now we need to compare and check what is the current maximum product here, and what is the maximum product we already calculated, and what is the current product we received, what is the maximum value that we will take it, that is 6. Now we will move j to next position, that is j equal to 2, that means this number. Now we'll multiply this current product with this number, this is minus 2, right? 6 minus 2 minus 12. So in this case we'll compare minus 12 and 6. 6 is the maximum, right? 6 only will come here. Next one is will increment the j, that is j equal to 4, sorry, j equal to 3 and the value is 4, and here minus 12 is there. Minus 12 into 4, that is 48. What 48? Minus 48. And here still 6 is the maximum value when compared to these two values. This is the case when j equal to I equal to 0 and j is actually moving with all the numbers. Now let us now what we got, the max pro value is maximum product is 6, right? Let us move on now. Let me take red color only. Now I equal to 1 and j equal to 1. Okay. So in this case, whatever the current value we have, that is the current product, that is equal to 3. That is CP is again initialized with 1 and 1 into 3 is 3. And maximum product we already received what? 6 here. So we'll keep that 6 here. Now j equal to 2. I will keep 1 only. Now I j equal to 2, that means we'll come here, and the current product is 3. 3 into minus 2 minus 6, and current maximum is, I mean max product is 6 even now. Now j equal to 3, that means 4 minus 6 into 4, uh, minus 24. Still 6 is the maximum. Okay. Now let us take increment the I value. Currently also we got the maximum product is 6 only. So I equal to 2 and j start from 2, and the current product is 1 initialized, and 1 into whatever the j position 2 is minus 2, that means minus 2. And maximum product we calculated till now is 6, that is this one, previous one. Now j will increment j to 3, that minus 2 into 3 is minus 8, and 6 is the maximum. And again we will increment the j, sorry, I equal to 3, and j start from third position, that is 4, and current product is 4, and maximum product is 6. So you don't, no more elements we have, that's it. The maximum profit, maximum product 6, that we will return. So this is actually brute force solution. This the time complexity of this solution is big O of n square, right? So we will try to solve one more way, is called some optimized way with O of one time complexity. But here we will take some examples, some extra variables, and then we'll try to manipulate it. Okay, we try to calculate the maximum product subarray, maximum subarray product basically. Okay. Okay, let us take the same elements. This solution is actual second solution with some optimized. Okay, optimized one, and we will take linear time complexity, that is big O of n. Okay, let us take the input, same input, that is I will write down again anyway. It's a not too much numbers are there. 3 2 3 minus 2 and 4, right? Okay, in this one what we will do is we'll try to start from I mean we'll try to iterate the each number. Before that, what we will do is we'll try to initialize uh, uh, current max, okay, and current minimum, and current product, whatever the return value we have to, sorry, max product, okay, whatever the value we need to return. So what we will do, we will initialize all these values with 2, first value. Okay, when we move to next number, what we will do is, and we will check this any number, this number is actually, example, this number is less than 0, that means negative. What we will do is, uh, we will come to this one. So what we will do is we need to calculate current max will be current max will be max of maximum of whatever the number we are taking, that number, comma, the maximum into, and the number what we are at position I. So this one, what is the value we'll get? Max value here is 3. 2 3 is 6. 3 and 6, max value is 6. So when I equal to 1, current max will become 6. Similarly, we need to calculate the minimum of, to calculate the current minimum, we need to calculate a minimum of current number, and product of current minimum is 2, and the current value is 6. Here also minimum is 3 at position I. And maximum product, what we will do is we need to calculate max of, we need to pick the max of what is the C max and current max. Current max and already multiplied product. Okay. So what value we will get here is 6 comma 2. 6 is the maximum. So in this position we will get the 6 as uh, the written value. Let's increment I value, that is I will become 2 now. Again apply here. So now what we will do, I will erase these things. Don't confuse. Okay. Okay, now let us take I equal to 2, that is minus 2. And here what we will do is Cmax will be Cmax equal to, what is the value at I position is minus 2, and what is the value at current max? 6 into current number minus 2, that is minus 2 and minus 12. What is the maximum value? Minus 2. So it will come minus 2 here. Similarly, Cmin equal to minus 2, comma, what is the value here? 3, right? 3 previously, and 3 into minus 2. What will come? Minus 6, right? Minus 2. But basically like 3 into 2 minus 2, that is minus 6 comma minus 2. What is the minimum value? Minus 6. So C min will become minus 6. What is the maximum value from minus 2 and 6? 6, right? So in this case what we need to do is, in when the value is minus 2, we need to swap, actually we need to swap the current max and current min will be current min and current max. So in this case what happens, what happened when we were coming to next coming to this value, I mean when the negative value comes, so we need to swap previous values. That means this value could have become 6, okay, and this value could have become 3. Now if you calculate here minus 3 and 2, I mean 3 minus 2, that is minus 6. Okay, here you will get minus 2 into 6 actually. Here actually what will become? Minus 6 only here. So next we will increment the I equal to 3, that is 4. Now we will take the minimum value 4 comma here minus 2 into 4, that is minus 8. So 4 is the max value, C max. C min time will calculate minus 4, and here what we will do is 4 into minus 6, right? uh, 28 minus 28. this one. That is the minimum value, right? And current max anyway, we will get the 6. So in this collision also, we will get the max product of subarray is 6 only. So this value will return. So this is the one of the optimized solution, and this is the brute force solution. Now let us try to write the solutions for the let us solve these problems with brute force as well as the optimized one. Okay, let us see if we'll check it out. If nums is equal to 0, just return 0. Otherwise what we'll do is max product is equal to nums of 0, right? And we'll just try to just for I equal to 0, I less than length of nums I plus plus. Here current product we will initialize with 1 because we need to multiply, that's why. For j equal to I and j less than length of nums and j plus plus. So here what we will do is current product star equal to, that means we will initialize with nums of j. Okay, and we will try to makes the max product equal to max of current product comma max product. We just return the max product. So we don't have the method called max. We'll write that one. Oops. Max of a comma b int if a is greater than b, return a, otherwise return b. Fine. So once we will just try to see, this is the brute force, and this is the mm, brute force with O of n square time complexity. Okay. Okay, let's run this and see what happens. Any syntax related stuff and all. Okay, all good. Test cases got passed, right? Basic test case. We'll run the algorithm for the other solution, O of n solution. Okay, that is also very simple only. So anyway, max product we have taken here. So what else we need is, as we discussed, we need current max and current min equal to, we will initialize with nums of 0 only for both. Okay, so once we initialize the even max product also, we initialize it with first value only. So now what we will do, we will try to iterate from I equal to 1 to length of nums I plus plus. Now as we saw, right, if now you will get the clarity why I told if nums of I is less than 0, we are just trying to swap that one, current max comma current min equal to current min comma current max. We are just initializing these two values. Okay, otherwise what we'll do is current max equal to max of current number, whatever the number we got, nums of I comma current max product of current max and nums of I, right? And current min also similarly, min of minimum of nums of I comma min c min into nums of I. and max product is equal to max of C max comma max product whatever we calculated. And here I need one more function for minimum A comma B teaser teaser if A is less than B return A, otherwise return B. Okay, I think this should work. We'll see any compilation issues or something. Oh, funk. Okay, what is the problem? Uh, okay, it's typos. Okay, these test cases are passing. We'll submit this code and check it out. Okay, all good. That's about the this maximum product subarray problem, and we discussed the two solutions. One is brute force, and another one is optimized solution with big O of n time. That is linear time complexity.